Haleakalā, or the East Maui Volcano, is a massive shield volcano that forms more than 75% of the Hawaiian island of Maui. The western 25% of the island is formed by another volcano, Mauna Kahalawai, also referred to as the West Maui Mountains. The tallest peak of Haleakalā, at 10,023 feet, is ʻUlaʻula. For the summit one looks down into a massive depression some 11.25 kilometers across, 3.2 kilometers wide, and nearly 800 meters deep. The surrounding walls are steep and the interior mostly barren-looking, with a scattering of volcanic cones. History. Early Hawaiians applied the name Haleakalā to the general mountain. Haleakalā is also the name of a peak on the southwestern edge of Kaupo Gap. In Hawaiian folklore, the depression at the summit of Haleakalā was home to the grandmother of the demigod Maui. According to the legend, Maui's grandmother helped him capture the sun and force it to slow its journey across the sky in order to lengthen the day. Geology. According to the United States Geological Survey (USGS) Volcano Warning Scheme for the United States, the volcano alert level for Haleakalā as of August 2015 was normal. A normal status is used to designate typical volcanic activity in a non-eruptive phase. Haleakalā has produced numerous eruptions in the last 30,000 years, including in the last 500 years. This volcanic activity has been along two rift zones, the southwest and east. These two rift zones together form an arc that extends from Lepers Bay on the southwest, through the Haleakalā crater, and Tehana to the east. The east rift zone continues under the ocean beyond the east coast of Maui as Haleakalā Ridge, making the combined rift zones one of the longest in the Hawaiian Islands chain. Until recently, East Maui Volcano was thought to have last erupted around 1790, based largely on comparisons of maps made during the voyages of Lepers and George Vancouver. Recent advanced dating tests, however, have shown that the last eruption was more likely to have been in the 17th century. These last flows from the southwest rift zone of Haleakalā make up the large lava deposits of the Ahihikina-ʻU Lepers Bay area of South Maui. Contrary to popular belief, Haleakalā crater is not volcanic in origin, nor can it accurately be called a caldera. Scientists believe that Haleakala's crater was formed when the head walls of two large erosional valleys merged at the summit of the volcano. These valleys formed the two large gaps, Puʻu on the north side and Kaupo on the south, on either side of the depression. MacDonald, Abbott, and Amp Peterson state it this way: Haleakalā is far smaller than many volcanic craters. There is an excellent chance that it is not extinct, but only dormant, and strictly speaking it is not of volcanic origin, beyond the fact that it exists in a volcanic mountain. Volcanic hazard on the island of Hawaii. Lava flow hazards are rated on a scale of 1 through 9, with 1 being the zone of highest hazard and 9 being the zone of lowest hazard. For example, the summits and rift zones of Kilauea and Mauna Loa volcanoes are rated hazard zone 1. Using this same scale, preliminary estimates of lava flow hazard zones on Maui made in 1983 by the U.S. Geological Survey rated the summit and southwest rift zone of Haleakalā as hazard zone 3. The steep, downslope areas of the Kanaio and Kahikini-Hapira and the area north of Hana are rated as hazard zone 4. Other areas of Haleakalā are rated comparable to the lava flow hazards of Mauna Kea and Kohala. These high-hazard estimates for Haleakalā are based on the frequency of its eruptions. Haleakalā has erupted 3 times in approximately the last 900 years. By way of comparison, both Mauna Loa and Kilauea have erupted more than a dozen times each in the last 90 years. Waialae has an eruption rate comparable to Haleakalā. All of Waialae is rated as hazard zone 4. However, the frequency of eruption of a volcano is only one of the criteria on which hazards are based. The other important criterion is the lava flow coverage rate. Using the preliminary dates for Haleakalā flows, only 8.7 square miles of lava flows have been emplaced in the last 900 years. In comparison, approximately 43 square miles of Waialae covered with flows 900 years older, younger, and approximately 104 square miles on Kilauea and 85 square miles on Mauna Loa covered by lavas less than 200 years old. Thus, Haleakalā is a distant fourth in coverage rates. Modern uses. National parks surrounding and including the crater is Haleakalā National Park, a 30,183-acre park, of which 24,719 acres are wilderness. The park includes the Summit Depression, Kipahulu Valley on the southeast, and Ohio Gulch, extending to the shoreline in the Kipahulu area. For the summit, there are 2 main trails leading into Haleakalā: Sliding Sands Trail and Hailemasu Trail. The temperature near the summit tends to vary between about 40 degrees Fahrenheit and 60 degrees Fahrenheit, and, especially given the thin air and the possibility of dehydration at that elevation, the walking trails can be more challenging than one might expect. Despite this, Haleakalā is popular with tourists and locals alike, who often venture to its summit, or to the visitor center just below the summit, to view the sunrise. There is lodging in the form of a few simple cabins, though no food or gas is available in the park. Astrophysical research, because of the remarkable clarity, dryness, and stillness of the air and its elevation, as well as the absence of the lights of major cities. The summit of Haleakalā is one of the most sought-after locations in the world for ground-based telescopes. As a result of the geographic importance of this observational platform, experts come from all over the world to take part in research at Science City, an astrophysical complex operated by the U.S. Department of Defense, University of Hawaii, Smithsonian Institution, Air Force, Federal Aviation Administration, and others. Telescopes and lasers are used to measure the Earth's plates and the processes of plate tectonics. The location where 2 plates meet is called the plate boundary. Plate boundaries are commonly associated with geological events such as earthquakes and the creation of topographic features such as mountains, volcanoes, mid-ocean ridges, and oceanic trenches. The majority of the world's active volcanoes occur along plate boundaries, with the Pacific Plate's Ring of Fire being the most active and widely known today. These boundaries are discussed in further detail below. Some volcanoes occur in the interiors of plates, and these have been variously attributed to internal plate deformation and to mantle plumes. Some of the telescopes operated by the U.S. Department of Defense are involved in researching man-made rather than celestial objects. The program is in collaboration with defense contractors in the Maui Research and Technology Park in Kihei. The astronomers on Haleakalā are concerned about increasing light pollution as Maui's population grows. Nevertheless, new telescopes are added, such as the Pan-STARRS in 2006. Transportation. A well-traveled Haleakalā Highway, completed in 1935, is a road mainly composed of switchbacks that leads to the peak of Haleakalā. The road is open to the public and is a well-maintained 2-lane highway containing many blind turns and very steep drop-offs. Local animals, including cattle, are often encountered in the roadway. The Park Service charges a vehicle entrance fee of $20. Public transportation does not go through the park, but tour buses visit the summit regularly. Cycling and horseback riding are other popular ways to explore the park. There are a few tour guides on Maui that pick people up at the hotels, and outfit them with a bicycle to glide down the road from just outside the national park boundary. Tour operators used to run bike rides down the entire 27 miles from the summit, but in 2007 the National Park Service suspended all commercial bicycle activity within the park boundaries, following multiple fatal accidents. Some tour operators now offer a modified version of the service which descends 6,500 feet from outside of the national park. Climate.